the power to which the concentration of that reactant is raised to in the rate equation. Now, order indicates how the concentration of a reactant affects the rate of reaction. And the only way to find the order of reaction is by experiments. So it's zero order with respect to A, so doubling the concentration of A has no effect on the rate of reaction. So rate is proportional to the concentration of A to the power of 0. Or rate equals a constant, which will give the symbol K, concentration of A to the power of 0. This time we're going to say that B is first order. Now if we double the concentration on B, because it's first order, the rate will double. Now rate is proportional to the concentration of A to the power of 1, or rate is proportional to the concentration of A with an invisible 1. It's up to you whether you put the 1 in or whether you don't. Rate equals the constant K times the concentration of A to the power of 1, or rate equals K concentration of A. Now this time it's second order with respect to A, so doubling the concentration of A quadruples the rate. Rate is proportional to the concentration of A squared, or rate equals the rate constant times the concentration of A squared. So if the reactant concentration doubles and it's zero order, then there's no change or no effect on the rate. If the reactant concentration doubles and it's first order, then the rate doubles. If the reactant concentration triples and it's first order, then the rate triples. If the reactant concentration doubles and it's second order, then it's going to quadruple the rate. Tripling the concentration of a second order reaction makes the rate go up by 9 times. Quadrupling the concentration of reactant and its second order makes the rate go up by 16 times. Now rate equals K, which is the rate constant, times the concentration of A to the power of 1, times the concentration of C to the power of 1, times the concentration of D to the power of 2. Now the lowercase k is the rate constant. Now the overall order for this reaction is fourth. You simply add orders. Now the units. So rearranging to make K the subject, K equals rate over that. So it's going to be moles per decimeter cubed per second divided by, now cancel one of them out, add those three together, bring it up to the top side, and it becomes dm plus 9 mole to the minus 3 s to the minus 1. It's got a fast rate of reaction. So we're doubling the concentration of A, which is first order, so we double the rate. We double the concentration of B, which is zero order, so we multiply by 1, and there's no effect on the rate. We double the concentration of C, which is first order, so we double the rate. And we double the concentration of D, which is second order, so it goes up by 4. So the overall increase in rate is going to be 4 times 2 times 1 times 2 is going to be 16. We can use colorimetry because iodide ions are colourless, whereas iodine is brown. Now there's the rate equation found from experiments. The peroxide disulfate is first order and the iodide ion is also first order. The overall order, now remember, you add the orders, so it's going to be second order. Now if the concentration of all reactants are doubled, the rate will increase by what factor? Okay, so let's double the concentration of peroxide disulfate, which is to the power of 1, and we're going to double the concentration of iodide, which is also to the power of 1, so it's going to be 4 times the rate. If we tripled the concentration of peroxide disulfate and iodide, then it's going to be 3 to the power of 1 times 3 to the power of 1 equals 9 times the rate. Now you may want to pause the video until you've worked that out, but it will work out to be dm plus 3 mole to the minus 1 s to the minus 1. We could use colorimetry because bromate 5 ions and bromide ions are colorless, whereas bromine is brown or orange-brown. Now there's the rate equation found by carrying out experiments. So it's going to be first order there, and second order there. Now the overall order, remember we just add the orders, so it's going to be fourth. Now if the concentration of all reactants are doubled, the rate will increase by what factor? So it's going to be the bromate 5 is 2 to the power of 1, the bromide is 2 to the power of 1, and the hydrogen ions are 2 to the power of 2, makes a total of 16 times the rate. Now if the concentration of all reactants are tripled, it's going to be 3 to the power of 1 times 3 to the power of 1 times 3 to the power of 2, which is going to be 81 times the rate. So it's going to be 3 to the power of 1 times 2 to the power of 1 times 0.5 to the power of 2. And that equals 1.5 times the rate. So you may want to pause the video until you've rearranged that and worked it all out. And it works out to be that. We could use colorimetry because iodine is brown, iodide ions are colourless, and the organic compound containing iodine is also colourless. Now there's the rate equation found by carrying out experiments. So if a species appears in the rate equation but not in the balanced equation, then it must be acting as a catalyst. Now the order with respect to propanone is going to be 1, hydrogen ion is going to be 1, and iodine is not in the rate equation, so it's going to be 0 order. It's going to be second order overall. It's going to be 2 to the power of 1 times 2 to the power of 1, so the rate increases by 4 times. If we triple the concentrations, then it's going to be 3 to the power of 1 times 3 to the power of 1 equals 9 times the rate. It's going to be 0.5 to the power of 1 times 3 to the power of 1, so the rate is going to increase by 1.5 times. Now you may want to pause the video until you've rearranged that and worked it out, and it's dm plus 3 mole to the minus 1 s to the minus 1.